Here's problem 28.7. In the figure, if R is equal to 30 ohms, what is the equivalent resistance between points A and B? Now if I look at this network, none of the resistors are actually in series with each other. To be in series, they must be along the same line so that the same current has to flow through both items. And at this configuration, none of the resistors have that situation. But we do have a parallel combination right here. So let's do that first. And that R parallel will be product over the sum, R times R over R plus R, which would be R squared over 2R. One of the R's cancel out, and it's just R divided by 2. Or I could have just said it should be R divided by N being 2, so it's R divided by 2. Alright, so the circuit now looks like this. I have a resistor R and R divided by 2, and then down below here I have another R, and here's point A and here's point B. Alright, so now I do have a series combination. I have an R with an R divided by 2. If I add those together, my circuit now looks like this. R down here, a 3R divided by 2 up there, and then here's point B, here's point A. Okay, now the 3R divided by 2 and the R are indeed in parallel. They're connected on both ends. So we can do product over the sum for that, and that'll be our R equivalent. So R equivalent is going to be product over the sum, 3/2 R times R over 3/2 R plus R. And that's going to be equal to 3/2 R squared over 5/2 R. One of the R's cancel out, and the halves cancel out, and so this is equal to 3/5 R. So that's our R equivalent. Since R is equal to 30 ohms itself, this would be 3/5 times 30 ohms, which would be 90 divided by 5, which should be 18 ohms. So the equivalent resistance of this circuit between A and B is 18 ohms. We could write it as just one equivalent resistance from A to B, and that is 18 ohms. Answer.